Thank you. My name is Giorgio Calarco, and my tutor is Professor Maurizio Casoni. And the aim of my presentation is to sketch out a possible approach based on virtual networks and software routers for the design of an emergency operations center. First, I will depict the general architecture of we started from, and then I will introduce the scope of our study. And then I will show you the hybrid testbed we are developing. And finally, I will resume some preliminary results. And let me now focus on a very general architecture for an emergency network. We can have several actors and many technologies involved. And for instance, we can have a personal area network with wireless sensors, and then an access network at the incident area, involving first responders and mobile emergency operation centers. And we can envision also to have a WiMAX broadband connection between the mobile emergency operation centers, and then a satellite link using, for instance, DVB RCS as a main backhaul link to the emergency operation center, and possibly Tetra or 3G connection as a backup backhaul connection. And I want here to sum up the scope of our study. And our goals are given a certain architecture to determine the performance limits of the network infrastructure, and then verify if this proposal is flexible and scalable and reliable enough for our purposes, and possibly to study end-to-end QoS or security schemes, but with respect to the traffic patterns of the typical applications which are involved. And to do all this, we need a tool to evaluate and compare several network architectures to guide the development of the responder platform. The main problem is to choose a proper tool. A conservative approach is based on physical testbeds, but in this situation, we should have a SAT link and WiMAX connection involved, and this could be very expensive and very time-consuming. And another approach is using pure simulations, but they are usually very far away from the final equipment that we want to install on board the MIOC. So we have chosen a hybrid approach that is a hybrid testbed in which we have emulators which run virtual networks and connected by means of a real IP router to compose a certain network infrastructure. And the main benefits of a hybrid approach are that it is open, it's flexible, and it offers realistic MIOC forwarding performance and repeatable evaluations. It allows a step-by-step deployment towards the final equipment, and it's also technologically closer to the final equipment installed on board the MIOC. And a conservative approach is to use several PCs to run several emulators, but we want to make a step forward and to run several emulators in parallel onto a single hardware platform. So let me now move on to the illustration of our testbed. We can envision to have just two PCs connected by Ethernet links, and then we can install a software IP router on one of them and a virtual machine host or containers, which is a different technology, onto the second PC, and then create several virtual machines, and inside each of them we can run a different emulator. For instance, a Wi-Fi emulator, a satellite emulator, a WiMAX emulator, and so on. So using these components, we can create a specific architecture that we want to study and investigate. And for instance, a basic example is to have a Wi-Fi emulator which injects packets toward the router, and then it forwards them to the satellite emulator, to the satellite channel, and we can study this particular configuration, for instance. And let me just clarify which software tools we are going to use. For the router, we have chosen to use the Click Modular Router, which is open, flexible, and very fast. For the emulation, we are using NS3, which is also quite fast and can also act as an emulator. That is, it can create real packets and to be integrated in a real-world testbed. And as I told you, we want to install a virtual machine host to have several emulators to run concurrently. And why virtualization? Because if we use virtualization, we can assign each emulator a controlled amount of computing resources, that is CPU, memory, network interface cards, and so on, as if it was running on a different PC. There are several virtualization techniques. Actually, we have chosen to study VMware, VirtualBox, and Linux containers, which is quite new. And let me now move on to the illustration of some preliminary results. We have started with using NS3 virtualized by the mean of Linux containers. We asked ourselves how fast it is and if it is feasible to simulate the emergency network's data rates. I just show you this unique slide, but it's important. We have increased the packet rate generation. Of course, there is a threshold, and but the most interesting thing is that using 500 byte packets, we can reach a throughput of about 175 megabits per second, which is much higher than the throughputs that we can expect from each part of the emergency network. For instance, Wi-Fi can generate 54 megabits per second, and so on. And another very interesting thing is that the results are the same if we use containers and also if we don't use containers. So the overhead introduced by containers is completely negligible. So let me just sum up the main results of our tests. We know now that containers are very promising and they offer no overhead for hosted applications. NS3 is fast enough for our purposes. And actually, we are testing NS3 over VirtualBox and VMware for a comparison. And the next issues will be to run many emulators in parallel and use them to build the whole emergency network infrastructure and verify if the performance for UDP and TCP applications and define the responder system and network requirements. That was the end. Thank you for your attention.